So in this objective, in objective 3, we're actually going to find the inverse of a linear function. In the previous objective, all we were doing was talking about what inverses are, that they undo each other, they switch the x and the y coordinate, and they reflected, the graphs are reflections across the line y equals x. So a couple things going on this slide, and that is Control Z on a Windows PC anyway is the keyboard shortcut for undo, and I have the line y equals x there graphed. It's at a 45-degree angle, perfectly 45 degrees, and then you see the reflection of that, so it's illustrating that property. If you look at the Flipping Math logo up here above my head, yeah, there it is, you see the same exact thing. The red dashed line there is the line y equals x, and then the two functions that are graphed are inverses of each other. Okay. Alright, so we've talked about what an inverse is, but we haven't actually written one ourselves. We've been given some and played around with them, had lots and lots of fun with them, but we haven't written any ourselves. But it's a piece of cake. Here are the steps. Step 1, Step 2, Step 1. That's interesting. I think there's a little bit of a typo there. Step 1 is, instead of having f of x, if you have it, take it out and put y in its place. We don't want to mess with it if it has f of x in it. It means the same thing anyway. Okay, so step 2 then, we're going to switch the x and the y coordinates, because that's what inverses do. They switch x and y. Let me switch this thing around and make that step 3. There we go. So on step 3, now you're going to solve that equation for y. So you take out f of x, put y in its place, switch the x and the y, and now solve that equation for y. What you have is the inverse of the original function. Let's try that right here. Find the inverse of f of x equals negative 2/3 x plus 2. So step 1, I'm going to take this and make that all y is equal to negative 2/3 x plus 2. What do inverses do? They switch the x and the y. So x is equal to negative 2/3 y plus 2. And now let's solve this thing for y. Subtract the 2 over. X minus 2 is equal to negative 2/3 y. In order to get rid of the negative 2/3, let's multiply by the reciprocal on both sides, which is negative 3/2. Okay, so I have negative 3/2 x. And I'm going to do the little arithmetic over here. A negative 2 times negative 3/2 over 1. The 2's will cancel. And I have a negative 1, essentially, times negative 3 is plus 3 is equal to y. Maybe you don't like to see it like that, so let's write that as y is equal to negative 3/2 x plus 3. Or, if you wanted to write it back in function notation, I write it as f inverse of x is equal to negative 3/2 x plus 3. I wonder if you notice anything about those slopes. Interesting. Interesting. Well, speaking of that, let y equals mx plus b. Find the inverse of y, and then what is the relationship between the slopes of inverse linear functions? So, when I have y equals mx plus b to find the slope, or to find the inverse, switch the x and the y. So I have x is equal to my plus b. Let's solve it for b. Subtract over the b, x minus b equals my. And now let's divide everything by m. Divide this by m, divide this by m. But I'm going to rewrite this so it looks a little bit, I don't know, a little simpler here. Y is equal to, I'm going to rewrite this as 1 over m times x. Would you agree? Good. And then minus b over m. Okay, so now here is the new slope, and here was the old slope. What's the relationship between those? Well, one's m, the other one's 1 over m. They are reciprocals. Not negative reciprocals like perpendicular slopes, just reciprocals. Also, look at what the new y-intercept is. It is the opposite of what the old one was divided by the slope. Okay. So here's a chance for you to practice your skills on writing inverses of functions. You got 3 of them to try on your own. Pause the video and then let's see if you're doing it right. All right, here's the answers. Voila. So the first one was x plus 4. Does it make sense then if I'm going to undo x plus 4, then it should just be x minus 4? And that's what you get. Okay, on number 2, 2x minus 1 becomes, for the inverse, a half x plus a half. Does this make sense? If I multiply something by 2, in order to undo it, I need to multiply that by a half. Also, what we talked about in the last exercise is that these slopes are reciprocals of each other. So 2, and then I have a half. Okay, and then on number 3, negative 3 halves x plus 1, its inverse becomes negative 2/3 x plus 2/3. And there you have it. So, to conclude this lesson, we've written equations of lines given a point and a slope, a slope and a y-intercept, or 2 points, using either the slope-intercept form of the line or a point-slope form of the line. We've also defined what inverses do, how they undo a function, how they reflect across the line y equals x because they take x and the y coordinates and they switch them. And then finally, we actually found some inverses of functions, of linear functions, by switching the x and the y coordinate and then just solving for y. So that concludes this lesson, and then here is your homework assignment.